Welcome to the GCSE Statistics Higher Session 1. This session is focused on charts and graphs and consists of 5 subsections: multiple, composite and percentage bar charts, Chloroplast maps, population pyramids, comparative pie charts and misleading graphs. Here are 3 different types of bar charts. If we have a look at the first one, this is a multiple bar chart, where there are equal gaps between the groups of bars, equal widths of bars, and no gaps between the grouped bars. Normally you get 2 bars together, but you can get 3. If we take a look at this example together here, frequency is proportional to height. If we have a look at this particular example, here we have 3 different categories, 3 different bars. All the bars have an equal width. They're together for the particular group for this year here, 2006, and there is equal spacing between the groups of bars. The key is important because it tells you which bar corresponds to which category. If we take a look at the second type, this is composite bar charts, and these are usually set as percentage bar charts, but not always. If we take a look at the particular example here, shown on the screen, this is a bar chart that vertically maps the different categories. So here we have 3 different years and 3 different medals: gold, silver and bronze. You'll notice that we can't use different colours because we're working in black and white in exam papers, so we use shading or lines to note the different sections of the composite bar chart. Similarly, for percentage bar charts, exactly the same as composite bar charts, but here the proportion of the internal category is proportional to the height. There's no knowledge of actual frequency, and this is similar to a bar chart. Here we're working in percentages, so we're just seeing the proportion. Here we have 3 different types of metals, and we can see here each brass, bronze and pewter, what it is made up of, and this is in percentages. So example number 1. The multiple bar chart shows information about the average price to the nearest 1,000 of 3 different types of housing in Newcastle and Bristol in August 2005. Here we can see we have the scale. The ones with a line across, these bars here, are for Newcastle, and shaded grey is Bristol. We're told that the average price of a flat in Newcastle in August 2005 was 130,000. and in Bristol, 160,000. We're asked first off to complete the multiple bar chart to show this information. So we're looking here at the flats, and we need to draw our 2 bars, one for Newcastle and one for Bristol. So take your ruler out, make sure you leave an even space from here, and then we're going for Newcastle as our first bar up to 130,000. Then across, same width bar, for Bristol, slightly higher, 160,000. So drawing our 3 lines on here, making sure we remember to connect across the top of the bar, keep it straight, and here. So they're the 2 bars drawing. We need to now make sure that we show which one is Newcastle and which one is Bristol. So across here for the Newcastle one, we're going to put some lines onto this bar, in the same way that the other bars have done, in accordance with the key that has been given to you in this question. And then for Bristol, take your pencil out and shade in the bar here. Okay, moving on to the next part now. We're asked, what does the multiple bar chart show you about the average price of detached houses? So we're looking here at detached houses. 1 mark is available. There's 2 things that you could say to get this mark. First off, we can see that the price of detached houses is much more than terrace, semi-detached and flats. So the detached are the most expensive type of housing. That's because the bars are higher than all the other 3 different types of housing. Now we might want to have a look at the comparison between Newcastle and Bristol. So a second thing to get the 1 mark could be making a comparison here by saying Bristol detached, more expensive than Newcastle. So either of those two comments will get the 1 mark available. Then you're told if you had 150,000 to spend on housing in Newcastle in this year, August 2005, which type of housing were you most likely to be able to buy? So taking your ruler out here again is going to be helpful to identify across the 150,000 mark. So we're looking here and we're looking at take another pen. We're looking at Newcastle, so we're focusing in on the first striped bars. So here we could buy a terrace house. Can't buy a semi-detached because the price is above the line. Same for the detached, and a house is affordable, a flat here is affordable below the line of the amount of money that we have. So which type of housing are you most likely to be able to buy? Either a terrace or a flat. Either one of those answers will be awarded the 1 mark. Example number 2, focused on composite bar charts. This composite bar chart shows information about the metals used to make brass, bronze and pewter. We saw this on the key fact page. We're then asked 3 of the following statements are true. First, bronze is made from 3 different metals. Look at the bronze here. 1, 2, 3. Each one of these 3 metals are shown here in the composite bar chart, so this is correct. Second statement, in pewter there is a large proportion of tin. We look here at the pewter and we're looking for a large proportion of tin. Tin is the stripes. Here we see that we have almost 95% of the pewter consists of tin. So yes, in the pewter, there is a large proportion of tin. This statement is also true. The third statement is that 50% of brass is zinc. Let's have a look at the brass column over here now. Zinc is the grey shading here, and that goes from 100 down to 60. So that's actually 40%. So the statement here of 50% of brass is zinc is not true. It is only 40%. The fourth statement, there is copper in brass, bronze and pewter. Copper is the solid black part. We have it here, here and here. Even though it's a small part proportion, it's still present, so yes. Then just checking the last statement, it asks for 3 of the statements being true, so this one must be incorrect. Let's check. In bronze, that's this one in the middle here, there is more tin than copper. There is more tin than copper. So we're looking at tin, this section, is more than this section. No, we can see here that the solid line is significantly more, so this is false. Example number 3, composite bar charts, not percentages. Here, the composite bar chart shows the information about the numbers of gold, silver and bronze medals won by the UK in the Olympic Games in 1992, 1996 and 2000. We can see here on the right that we have a key for each of the sections of the composite bar, and we have our 3 years shown here. We're asked to write down the total number of medals won by the UK in 1996. So looking here on our 1996 column, we're looking here at bronze, silver and gold. We're looking at the total, which is 15. We're then asked to work out the number of gold medals won by the UK in 1992. So these 2 parts are testing whether you can read your information from the composite bar chart. So we're looking at gold in 1992. So for this question, part B, we're looking at 1992 and we're looking at gold, the section here. we can see here, if we read across, here is 17, and up here we have 22. So to find out the actual numbers, we take the difference. 22 subtract 17 gives us 5 gold medals in 1992. We're then provided with a table which shows the information of numbers of gold, silver and bronze medals won by the UK in 2004. So we're going to have to put this information onto the bar chart here. So we're going to be starting with bronze. In line with the other bars, they have the first section to represent the bronze. So taking your ruler and using the spaces here shown, our first part will go up to 12. So we're going here to 10, 11, 12. And here, move that one across, slightly lower, just in line, and then across here. So here we have our first section here to represent the bronze. Now we have a 9 silver. So we're going to have to add on another 9. So 12 plus our 9, so 12 plus our 9 will take us to 21. So we're going to extend our bar now. Up to now 21. And same here on the right hand side, extending our bar to 21. So that's to add on the additional 9 for the silver. And across. Make your lines as straight as possible. Same here on this one. And then gold, a further 9 for the gold. So 9 more for the gold. We'll add on 9 to 21, which will take us to 30. So the total, the composite bar chart for bronze, silver and gold extends all the way to 30. Make sure you add on your last part here for the last part of the bar. Now, making sure that we follow the key. Gold stays white. Silver, we need to include some lines in our middle section of our composite bar chart here, using the key that's been provided and used for the other bars, so keeping consistent. And then for bronze, we're going to need to shade in our bronze section here to show our 12 medals. Chloroplast Maps. These are maps which uses shades of colour to show geographically based information. There will be a key, as shown here on the screen, that will show the information contained in the different parts of the map. If we look here, we can see that at this location, C1, there is less than 5 tiles. So using the key, we can see how the information is located geographically. The really important part here is that obviously in the exam, this is going to be in black and white. So having not using colours, often they will use shades of grey or pattern to show the different sections located within the actual map. So the key part is really important to be able to interpret the Chloroplast map. Example number 4 here. Here we have a map that shows the number of successful planning applications in each region of England in the first quarter of 2007. Here we have our key, which is shown by different shades from white here through grey to the darkest solid black. We're asked to write down the name of the region with the smallest number of planning applications. Looking here at our numbers, the smallest is the white section, 0 to 5,000. The only set region here that is shaded using just the white is the northeast. Here, there is the smallest number of planning applications. We're then told that 3 regions had between 10,001 and 15,000 successful planning applications. That's this one. We're asked to write down the names of 2 of these regions. So there are many ways you can look straight away for this shading or through the process of elimination to make sure you have the correct places. First off, we can see it's obviously not the northeast. Then the next lightest are these 2 sections here, West Midlands and East Midlands. It's not there. It's not the darkest here for South East. And then we have the next darkest colour, so it's not this one and it's not this one. So after the southeast, southwest and northwest are the next 2 shades that are darker. We then have 3 remaining sections. All of these are the colour we are looking for: Yorkshire and Humberside, East of England and London. So these here are the 3 shades that correspond with the category that we're looking for. So any of these 3 answers will be acceptable for your 2 marks here: Yorkshire and Humberside, East of England, London. Any of those 2 regions need to be identified here in part B. Population pyramids. Population pyramids are used to show demographics, and they're usually in the context of comparison between male and female. Let's take a look at an example together. Example number 5. The 2 population pyramids show the percentages of men and women in each age group in the United Kingdom and in Northern Ireland. Let's have a look here. So these are 2 different places, United Kingdom on the left, Northern Ireland on the right. We have men and women, ages, age groups here in the middle, and then the percentage of the population. So let's look at the questions that we're being asked to interpret from these population pyramids. First off, we're asked to write down the age group which has the greatest percentage of women in the United Kingdom. So we're looking here in the United Kingdom, and we're looking at the women, and we're looking for the greatest percentage. So we're looking at which bar comes furthest out, and we can see that is this bar here. And the age group that corresponds to is 35 to 39. We're then told that 6% of men in Northern Ireland are in one age group, and we're asked to write down this age group. So looking now on Northern Ireland, looking on men, and looking for 6%. So if you take your ruler out, at the 6% mark here, drawing a line up and looking for which age group this corresponds with. We can see that all of these are larger, and this here is the age group corresponding to 6%, which we can see here is 50 to 54. We're then asked to make a comparison to compare the percentage of people up to the age of 19 in the United Kingdom with the same percentage of people up to the age of 19 in Northern Ireland. So we might want to section off the graph we're looking at. So if we take our ruler again and mark up to 19. So that's this section here we're looking at. This will focus you looking to the right part of the graph. Now, 1 mark is available, and we need to make a comparison between the 2 countries. So we're looking here in Northern Ireland and here in the United Kingdom and here in Northern Ireland. We can see here that there is a greater percentage of people in Northern Ireland. Look how far the bars are across. If we take 6 here, this is over. This is about 7. This one here is about 7.5. This bar here is almost at 8, so probably about 7.8. And again here, probably 7.7. This is for the women. Now it's matched here again on the men's side. Here we have 7%. Here almost 8%. Here we have over 8%. about 8.5, and here we have 8%. If we compare these to the United Kingdom, where this one is over 6%, and 1, 2, 3 are on or just below 6%. Same here for the boys' side, we've got one here on 6%, and these ones are just above 6%. Whereas in Northern Ireland, the percentages are more like 7 or 8%. So when we're comparing the percentage, we're not looking at male and female, we're looking at total, and we can see that there's a greater percentage of people less than 20 or up to the age of 19 in Northern Ireland. Comparative pie charts. Now these pie charts are normal in the sense that they contain information about the relative proportion. However, unlike normal pie charts, they contain information about the relative size, how many of the total populations. Area is proportional to frequency. Even if one population if you're given one population, you can find the second by comparing the ratios of their areas. So here, this should say here, if given one population, you can find the second by comparing the ratio of the areas. Now let's have a look at this example here. In comparative pie charts, you'll be provided with two pie charts. Here we can see that the area is bigger than the area here. And this is important in relation to the relative size of the total populations. We can see here that this section here, which relates to senior males, is the same here and here in terms of the proportions. So in 1980, 50% of the players at this squash club were senior males. And again, in 1990, 50% of the players were senior males. So the proportion is the same. However, we can see here that from 1980 to 1990, the number has increased, the size has increased because the area has become larger. So here, the proportion is exactly the same. 50% of the players at the squash club were males, but actually the size, the number of males now at the squash club has increased because the area has increased. Misleading graphs. You need to know common things that are misleading about graphs and check for these when asked about this. Now, these are the 4 points that I would recommend you look for every time. First off, the vertical axis not starting at 0. Now, this is misleading because it leads to an exaggeration of the trend. It makes it seem bigger or smaller than it actually is. Another thing to look for that's common is a break in the vertical axes when comparing the two variables. This is a really common misleading feature. Another thing is in relation to 3D representation. This is for pictograms or pie charts because this doesn't show the proportions exactly in their same presentation if presented in a 2D. Also, a lack of labels on the axis can lead to a misleading aspect of the graph. So when asked about this, check through this and see if any of these things are present. There might also be things in relation to the thickness of the lines used or the shading to be able to draw your attention visually to certain aspects of the graph. Example number 7. Here we have a graph that appeared in the national newspaper. The graph is supposed to give information about the price in pence of buying a share in the Carphone warehouse. The paper said shares in Carphone warehouse have increased a lot over the year 2003. Now, write down one feature of the graph that makes this increase look greater than it actually was. So we're looking here for the common things listed on the previous slide. First off, does the vertical axis start at 0? No. So vertical axis does not start at 0. And this exaggerates the trend. So that's a really common thing, one feature that makes this graph look, the increase in this graph look greater than it actually is. And then it asks you for another misleading feature. So here we can see that the horizontal scale is not clear. What do these graduations mean between the year 2003 and 2004? So the horizontal or the x-axis scale is unclear. There's no proper axis label on this axis. You can see here we're just P. We're not exactly sure what that means. So no proper label on axes. And then also this line, the fact that the line is very thick and there's a shadow behind it. This is another misleading feature of this graph. The thickness and shadow of the line. It's now time for you to have a go at some questions. Press pause on the video and complete the question booklet. Once you've done as many questions as you can, come back to the video and press play, and we will go through the questions together. Question number 1. The table gives information about some number of male and female car drivers killed or injured in the UK in 1994. It also shows the percentage of those killed or injured in each of the 3 age groups. Use this information from the table to complete the composite bar charts below. So we have the information here for the percentages. We have a key where we can fill them in, and we have bars here ready for male and female. So, first step, let's take a look at the males. In the first category, we have 18%. So we will go up to 18 and draw a line across using your ruler at this point here. Now this is a composite bar chart, so we now need to add our next percentage. 18 plus 48 is 66%. So this time we're not going up to 48, but we're going up to 66. Across here, so that this section is 48%. And here we will have our leftover section, which will be 34. Going over to the female side now, we're going to do the same thing, starting with 16, so slightly lower than the males. Adding 16 to 52 gives us 68. So drawing a line across here, and then our remaining category here, 32% at the top. Now, before we move on, we need to distinguish between the 3 different sections on our composite bar chart. So we can use some shading. The choice here is yours. The first section I'm going to shade for the category 17 to 21. Shading here on the male and the female, and then marking it here in the key. The second section I'm going to do some lines across. So in this section here, some lines, diagonal lines across. And this is our section for the age group 22 to 39. Here, and same thing for the females. Marking it here into our key. And then for the last section, 40 and over, I'm going to leave this one blank, and that's the same here in the composite bar chart. We're then asked to calculate the number, not the percentage, the number of male drivers aged 17 to 21 who were killed or injured. So we're going to need to use the percentage from our table here. Males 17 to 21. We're looking at 18%. 18% of the total. So we have our total here along in the table. So we're looking to find the percentage, 0.18 times by 70,100. Multiplying this out, we get our answer of 12,618. This is the number of male drivers aged 17 to 21 who were injured or killed. Question number 2. The Composite Bar Chart shows the percentage of GCSE grades gained by males and by females in England in 2001 to 2002. We have our categories here with the key and male and female here. We're asked, did males or female have the biggest percentage of 5 or more A star to C? Well, let's have a look here at our key. The 5 or more A star to C is the solid black part. We're asking which one has the highest percentage, and we can see here it's females. We're then asked, in which category did males and females gain the same percentage? So it's not here and not here. We can see it's not here and not here. This one is bigger. We can see this one is bigger than this one here. So it's likely to be our white section here, 1 to 4 grades A star to C. But let's actually check that by calculating. So we can see here that this line comes across to 71 and here to 46. So the difference here needs to be the same as the difference here. Going across here on our line, we have 81 for this section, and here going across, we have 56. So if we subtract these, we will get the same answer, which is the same percentage for both of these, which is 25%. So which category had the same percentage, 1 to 4 grades, A star to C? We're then asked to work out the percentage of males that gained grades D to G only. So this category here we're now looking at is the next category, this one here and this one here. And we're looking at the percentage of males. So this is the category we need to calculate. So this here is 71 and here we have 94. So to calculate the percentage here, 94 subtract 71 gives us 23%. We're then asked to write down one reason why the choice of shading for the composite bar chart may be visually misleading. Now we're looking at the choice of shading. We can see here that the shading that they have chosen means that this part here stands out. So actually the black shading dominates visually. So that's the section of the bar chart that you immediately focus on. And this could be misleading. Question number 3. The diagram shows information about the sea temperatures for Peru in 1981 and 1983. We have a key here to show the different temperatures. And we're asked to put a cross in the box below that gives the sea temperature for Peru in month 3 in 1983 at a depth of 50 meters. So this first part is checking if you can read the Chloroplast map. So we're looking here on this one. This is the year it corresponds with. Depth 50, that's this one here. Month 3. Up and across, we're looking here at this box. The shading for this box is here, the same shading. So which one? 20 to 25. For 2 months in 1981, So I'll change colour here. We're looking at 1981 now, this Chloroplast map. The sea temperature of Peru was between 15 and less than 20. 15 and less than 20 is the very light shading here. At a depth of 100 metres. This is 100 metres, and we're looking for this shading. The only 2 months where this shading is present is here, month 4 and month 5. 4 and 5, which corresponds to April and May. We're then asked to use the diagrams to compare the sea temperatures for Peru in 1981 and in 1983. We've got 2 marks, so we need to say at least 2 things. So first off, we can say that it's hotter in 1983. Why? Because there's more darker shading. This is the high temperature, more darker shading overall. We can also say that it is warmer for longer in 1983. Warmer for longer. We can see here, for example, at 0 meters, the really hot temperature, the hottest temperature, lasts for 6 months. Here at 0 degrees, we can see it only lasts for 4 months. At 25, we see it can last for 5 months. 2 years before, it was only lasting for 2 months. So this is related to the comment, warmer for longer. Another comment that could be made to compare is that there are higher temperatures deeper in 1983. So you can see here that in month 1, the temperature goes all the way down to here to 75 and it's still really hot. Whereas we can see here, we have the lower temperature at 0 and 25. It's not going as deep. Same thing here, we can see that this is lasting all the way down to 50 when it's only going to 0 on this one in 1981. And the last comment we want to make is around it being higher temperatures earlier. So we can see here that in month 1, it's warm, whereas in 1981 in month 1, it was the category below, the 20 to 25 category. So this might be a 4th comment that you can make when comparing the sea temperatures in Peru between 1981 and 1983. Question number 4. The diagram shows information about the population of Camden in 2001. We're asked, what is the name of this type of diagram? Here we have population, we have 2 categories, men, women, percentages. This is a population pyramid. Using the diagram to answer the following questions about the population of Camden. Write down the age group that has the largest population. The age group with the largest population is the age group that has the biggest bar. The largest bar, the highest percentage. We can see here that our 25 to 29 category is the longest here, the biggest, the highest percentage for women, and the same here for the men's side. So this here is the age group that has the largest population. We're then asked to work out an estimate for the percentage of female population under 20 years old. So looking here, we're looking on the women's side for the female population under 20. So this here, all of these bars. Now we need to estimate the population. It's not going to be precise because you can see here, we cannot see the exact percentages. Drawing a line up, we can see here, this here is 5. We've got 4, 5 and 6. All of the percentages are between 4 and 6. If we look here for 5, our first one is closest to 5. Our next percentage is here, near to 4. Here we have one right in the middle here, which will correspond with 5 approximately. And here for the 0 to 4 age group, not 5, not 6, halfway, 5.5. Adding up these 4 estimates for the percentage, we will get 19.5%. So here, using the method of estimation that I've shown, we get 19.5. However, on the exam, the examiner will allow any answer in the range of 17 to 22. So check that your answer is within these limits, 17 to 22. We then are told about a further diagram which shows the population of Northern Ireland in the same year, 2001. We're asked to give one similarity and one difference between the population of Camden and the population of Northern Ireland. So we are going to be comparing and contrasting, looking for similarities and differences. Now, note that you only need one, but there are a number of different options here of things that you can say and notice about these two population pyramids. The first thing that you will notice that is the same about Northern Ireland and Camden is when we look at the top end of the pyramid at the older age categories, the women's column is bar here is always larger than the men's. The women's here is larger, larger, larger when comparing. And it's the same here in Northern Ireland. So the first similarity that we will notice is that women live longer than men. They have a higher percentage of the population here for women compared to men, and that's the same in Camden and Northern Ireland. However, when we look at population in general, we can say that a similar feature is that the men and women are generally around the same. So here we can see that our 20 to 24 category is a little bit smaller for the women compared to the categories above and below, and it's the same here for the men. We can see here the category here is bigger, the category here is bigger, category here is smaller, category here is smaller percentage. So actually, when you look at the population in general, we can say that women and men have similar, not identical, but similar percentages in each age category. And actually, when you look at the 40 to 45 category, both here and in Camden, they're actually almost the same. So for this age group, there is the same proportion. So a third thing that you may notice here is the 40 to 44 category having the same proportion. Okay, moving on now to differences. So things that are not the same about the population pyramids shown here in the information in the population pyramids of Camden and Northern Ireland. First off, we can see that the shape here of the pyramid for Camden is very different to the shape here for Northern Ireland. But what does that mean? Here we have a smaller part underneath our age group here. So the children in Camden, there is a smaller proportion. Whereas here, the children are in about the same proportion, the 0 to 4-year-olds, about the same as the 50-year-olds. So it's more evenly distributed. So one of the main differences you can see already is that in Camden, there is a smaller proportion of children. And you can say that in another way by saying that it's consistent in Northern Ireland or similar to the other age groups. A further thing that you will notice when you look at Camden, there's a greater proportion of 20 to 30-year-olds compared to any other age group. When we look here from 20 to 30, it's much, much larger than it is in Northern Ireland. So this is the particular thing around the differences that Camden has a greater proportion 20 to 30-year-olds compared to other age groups. And again, that's not the same here for Northern Ireland, because the 20 to 30, this category, well, it's about the same as the 30 to 40s and the 10 to 20-year-olds. It's not particularly different. So that's two really key differences about the population of Camden and Northern Ireland. Question number 5. 5 shops in Whitehaven sell both DVDs and videos, so videos and DVDs. The comparative 2 pie charts we're going to compare show the percentage of each that was sold in the 5 shops in 1 week. The size of these bar charts is important. The percentages of the different shops are labelled here in the appropriate sections. We're asked to comment on the sales of videos compared to DVDs in Whitehaven. So we're looking at the sales of videos compared to DVDs. This pie chart is bigger. The number of DVDs being sold is bigger than the number of videos. So there are more DVDs. We're not comparing against the shops here. We're saying compare videos with DVDs. More DVDs. Why? How do we know? Because the size of the DVD pie chart is bigger. The area is bigger than the video. So here when we're comparing, we can compare the number in the total population. So there are more DVDs being sold than videos. We're then asked to discuss the relationship between the percentage of videos sold and the percentage of DVDs sold. So here now, when we're asking for percentages, we're talking about ratio, we're talking about proportion. This is no longer numbers. In each of the 5 shops, so we must make a comparison based on all of the shops. So there are a few things we can say here. We've got 1 mark available. So the first thing you can notice that when we look, the percentage of videos compared to DVDs is about the same. So when we look here, we're looking here at about roughly a quarter. Again here, roughly a quarter. So one thing that can be stated is that the percentage of videos compared to DVDs is about the same in all 5 shops. Look here, quarter, here, roughly the same. This one's a little bit bigger, but it's about the same. So we can say that the percentage is roughly the same, about the same. Now we can also compare more precisely, and we can see that the percentage of DVDs sold is greater than videos in C, D, and E. All of these percentages are higher than videos here. So this is in shop E, D, and C. Whereas when we look here at A and B sell more, the percentage is higher of videos. So we can then say the percentage of videos sold is greater than DVDs in shop A and B. So any one of those comments will be a comparison related to the percentage of videos sold and the percentage of DVDs sold. Question 6. Here we have a graph that gives information about regular household waste and recycling in England. We're asked to write down 3 features of the graph that are misleading. So we're thinking about that checklist. First off, vertical axis does not start at 0. First comment, vertical axis does not start at 0. Second thing we can see here, the break in the vertical axis. The break in the vertical axis. Both of these are exaggerating the trend. It's making it look like these two lines are coming closer together because they've missed a gap out here. Now, a third feature, we can see here that the lines look really thick. We wouldn't normally draw a line with such thickness. So this is another misleading feature. Lines, thick. We can see here that the axes are once again poorly labelled. Here we have 1,000 tons. This also makes it confusing. And here we have the years labelled, but again, not the clearest axes. So that might be something else you can write down for the third feature. But the most important ones are the first two, looking for the vertical axis not starting at 0, and here the break in the vertical axis. Question number 7. Parents can appeal against the secondary school their children are sent to. This graph from the Times Educational Supplement shows information about appeals from 1997 to 2002. We're asked to identify 2 reasons why this graph could be misleading. First off, look here. The vertical axis is not starting at 0. So vertical axis, you can call it the percentage, does not start at 0. And look at the effect of that. In this year here, it looks like no appeals happened because the line goes right down to the axis. But the appeals do happen. 2% of parents were appealing during this year. So this is a misleading feature. We can see here also that the shading and the thick line is another reason. So the shading, thick line makes this misleading. And then again, the fact that they've joined the points up. This is not a bar chart. It looks like something here is increasing. We can see the different gradients. And this is also misleading. We're then asked, does the graph show that the number, really key point here, the number of parents appealing in 2000, 2001 here, was greater than the number appealing in the year 1999 to 2000, this one. So here we're at this point, and here we're down this point. This point is higher than this point, but this graph does not show that the number of parents appealing here is higher than here. It does not show the number, it shows the percentage. So really important, does it show? No. It shows the percentage, not actual numbers. Really, really key point there. Question number 8. The pie chart gives information about land used in the UK. Here we have different ways the land is used. It's presented as a 3D pie chart. Describe 2 effects of the diagram that can be misleading immediately. The 3D effect. Why? Because it distorts the size. We can see here that this bit here for inland waterways looks tiny, whereas this bit here, the crop thing, looks really big. This looks really big at the front. This part here, other forms of agriculture, looks really small because of the way it's being presented in the 3 dimensions. We can also see that the fact that they've taken a part out of the pie chart is also misleading, and it makes it difficult to see the ratios. So one reason is this. A second reason is that taking or slicing part out makes it difficult to see the ratios. And again here, the choice of colours. A third reason that would also get you the mark would be around some colours stand out more than others. So we can see here our darker colours, This one here fades away. And again, this is a misleading feature of this graph. So some colours stand out more than others. So look for that shading and thickness of the line can be another feature which is misleading. We've now come to the end of session 1. Please revise the list here on the screen of subtopics and replay the video for any section that you would like to study again.